Hey guys, welcome to the house. I figure you're working hard studying your stoichiometry, so let me give you a couple little hints. I'm going to take you through like a quick little crash course on how to do stoichiometry if you're really stuck. I'll give you the conceptual way that's overarching that will get you to the right answer, how you can apply that conceptual way to a really basic, we'll just say iron reacting with oxygen equation, and then we'll show how to do that with dimensional analysis. I'm only going to use one color. I got my blue. Hopefully it works. And let's jump right into it. And I want you to feel really confident with your stoichiometry, finding the answer, and then how to do that with dimensional analysis. And the second way is kind of a hybrid between conceptual and dimensional analysis. So let's get rocking and rolling. I think everything's in view here. So let's say we got iron that's just reacting with our oxygen, okay? So we got iron, Fe, and that's reacting with oxygen, O2, and that reacts, and we'll say it's kind of like the steel wool burning. Done a couple little videos on that on the other channel, and I really like that one. Fe2O3 right there. If you want the states, that's not super important for us right now, but there are times that is important. And so step one, what if you had no idea what you're doing and I said to you, hey, I want you to find, if you have 5 grams of this, how many grams of this would that make? And without getting into, we'll just assume you have tons of extra, we'll call this the excess. You got tons of extra oxygen. There's no shortage of that. So what would I do here? Well, our big conceptual is we have to get to moles. So let me show you one way that it's the way that I like to do in class, and then I'll tie that into a larger conceptual understanding. So whenever you go, if you draw a little line that separates each one of these like this, if I draw my little lines that separate these, whenever I cross these lines that separate, I have to be in the mole. The mole is like the quintessential little chemistry value that we have to get to whenever we go from one thing to another. And in this case, we're going from iron to this iron Fe2O3, which is iron oxide. And if we wrote down the actual name for that and we figured out the charge, that would be iron 3 oxide, which you'll also have to know on your test. But what we're doing is we're going from grams down to moles, okay? So if we can get from grams to moles, the mole is how you cross any one of these lines. I cannot just go from grams to grams. I can't go from grams to moles. I have to get whatever you're given into moles, and then once I'm in moles, I can get that to the new moles of whatever it is I asked for, whether it be oxygen or this iron oxide. So the way that I would do that conceptually is I would say this grams needs to get to moles, like this. And the way that you get from grams to moles is you have to take your grams and divide it by the molar mass. So I'm going to divide this by the molar mass. And the molar mass is a great number in terms of iron. Okay, iron. Now I'm working off memory here, so if I get this wrong, I hope I don't get it wrong. Okay, pretty sure it has 26 protons. I'm gonna go check. I think it's a molar mass of 56.8, but I'm gonna double check that. Ha, it's a good thing I checked. Look, 55.8, that would have been so embarrassing. See that? Right there, 55.8. Whew, they don't have been like, should I even make this video? Okay, what was it? I'm too tired. You're probably too tired too. We'll push through together, 55.8. So this iron, 55.8. So when you're finding this molar mass, here's how the molar mass ties in. The 26 is the number of protons. That's the top number. This bottom number, which is kind of our protons and neutrons, there's a little more that goes into actually finding that number, but this is your molar mass right here, okay? I'll put Nm, that is my molar mass. So above whatever thing I'm working with, in this case iron, I write down, I just like to note that this is 55.8, and that's grams per mole. And so to get to moles, I would take 5 grams and divide by this molar mass of 55.8. For now, I'm going to say 55.8 is grams is equal to, and this is where this mole comes in, that's how many grams I have when I have 1 mole. Okay, 1 mole. That kind of crossed into the other line, but that's okay. And what does 1 mole mean? Okay, a mole is a number. It's like a dozen. So a mole is a dozen, a mole is not a dozen. A mole is like a dozen in that it's a set quantity. So like a dozen is 12. A mole is 6.02 times 10 to the 6.02 times 10 to the Michael Jordan, 23rd. So this mole is when you have 6.02 times 10 to the 23rd of something. You could have 6.02 times 10 to the 23rd eggs, soccer balls, basketballs, calculators, cats. You can have this many of anything. It's just a set quantity, like a dozen is 12. So in order for iron to weigh 55.8 grams, it means you have this many of them, 6.02 times 10 to the 23rd, and that is 1 mole of them. Okay, so grams divided by molar mass would get me to moles. Great. Now, how do I get from moles over to the thing that I actually need? Well, when I cross this line right there, I have to be in units of moles, which I am, and I use what's called the molar ratio. Okay, we use our molar ratio. And this molar ratio comes from when you balance an equation. So like on this equation, when I'm looking at it, there's no numbers out front. It's not balanced yet. So I need to make sure that my ions on this left reactant side are the same as the ions on my product side. The oxygens on this left reactant side are the same as the oxygens on my left product side. So for my ions, instead of going back and forth here, I'll just show you a quick trick. Whenever you see 3 and 2, that just tends to happen a lot, especially in the ones that I give you. We want to get that to the first number they both go into, and that's 6. So in order for there to be 6 oxygens on this side, I need O2 3 times. It's like I need O2, we'll draw it like this. Oxygen stuck to another oxygen. Oxygen stuck to another oxygen. Oxygen stuck to another oxygen. That's 1, 2, 3, 4, 5, 6 oxygens, but I have 1, 2, 3 of them. That is what this coefficient of 3 means that's out front. So my coefficient that's out front is how many of the molecule or ionic compound that I have. So in this case, I'm going to have 3 of these O2s. Now over here, in order to get 6 oxygens, I'm going to need this whole thing. So I'm going to need this Fe2O3 and Fe2O3. I'm going to need 2 of those because the O3 and the O3, that's 6 oxygens. So I put a 2 right out front. Now, how many irons does that mean that I have? Well, these 2s are each referring to the iron. So that means I have 2 irons and 2 irons for a total of 4 irons. So right over here, when there's no number, I need to put a 4 out in front. And that tells me that I have 4 irons. It's like I have that iron 4 times for this reaction to happen. Good so far? I'm gonna keep going. So this molar ratio, back to that. What you do to get from moles to moles is you take the number that you're trying to get to. In this case, we're going to grams. So I take the coefficient of the number that I'm trying to get to, which in this case is 2. That's where I'm going. So 2 is going to go on the top. And then I divide that by the number that I'm coming from. So that's the column that I just came from here. So that is from, okay? And in this case, what was my coefficient in front of iron? It was 4. So I put that balanced mole ratio number down there, and it's 2 where I'm going over 4 where I'm from. Okay, so once I find my moles, I'm going to multiply, I'll just put a multiply right out here, multiply by 2 over 4, and that will get me into my new moles that's in the column that I'm trying to find. And my new moles are now moles of iron oxide. I was in moles of iron, but when I cross this divide by using the mole ratio, 2 over 4, I now get into my new moles of iron oxide. And this column tells me that I'm now in iron oxide. Are you gonna jump in here too, twos? My cat's wanting to get in on the action. Very exciting stoichiometry. So our moles, now we need to get to grams. That was our ultimate goal. So I'm going up to here. So to get from moles to grams, I'm gonna multiply by the molar mass. But not the molar mass of the one that I had before, this new molar mass. So the new molar mass is, let me do that off to the side. I have a little room right here. So it's going to be 2 irons, and we just said iron was 55.8. So the iron part of this is going to be 55.8, and I have 2 of those. So I'll just multiply that by 2. Plus, and then we have 3 oxygens. So oxygen right here, and oxygen, here I'll draw it down underneath so you can see what that would look like on the periodic table. O, there's gonna be 8 protons, that's the atomic number, and then there is 16.0 is that atomic mass. So our molar mass, when we have a mole of those, is 16.0. So we have 16 times 3. So what is our molar mass going to come out to when we plug this in? I got my trusty calculator. We have 55.8 times 2, okay, 111.6, and then let's add that to 16 times 3, and that gets 159.6. Okay, 159.6. And that's in units of grams per mole. Grams per mole. Okay, so that's our molar mass. This is our molar mass of iron oxide, this iron 3 oxide. So when I have my new moles, I'm going to multiply by this molar mass right here, and that will get me into units of grams. That is my conceptual. Now, how I oftentimes have remembered these steps without doing the stoichiometry, and the stoichiometry is really important to learn. Okay, I don't want to downplay that, but how I remembered and literally got through college with this was, I would say the thing that I started with was my mole category over here. Okay, and we didn't get into all of these, but I'll just show you the ones that we did. So mass, which is grams, and then we talked about you could also go to particles over here, and other names for particles might be atoms or ionic compounds, but the particles is just how many of the thing there is. Whenever you leave the mole, you're going to multiply. Whenever you come back to the mole, you're going to divide. You're going to divide right there. And you have a conversion factor that's in between both those. So in this case, it's the molar mass and of the thing that it is. So like here, our molar mass was of iron. So my molar mass was 55.8. If I was talking about over here, my molar mass would be the molar mass of the new thing, our iron 3 oxide. It's all dependent on the category that you're in. And over here, the particles conversion factor is Avogadro's number. That's this number that we mentioned right here. That is 6.02 times 10 to the 23rd. Now there's one more we didn't really get to. Let me just show you in case you run into that or we do it a little bit later. This can cover that as well. And that's volume of when you're in a gas. I'll just put the gas state right up there. So when you're going to the volume, you multiply when you leave the mole, you divide when you come back, and that is 22.4 liters, okay? There's a little more that goes into that, but I'll just leave that there. So it has to be a gas at STP. So this is what we did right here. We took 5 grams and we divided by the molar mass to get to moles. Now, how did we get over to here? To get to a new thing, we go to our new category by doing going over from, and that gets us to our new moles, and we just do this exact same thing. So we got mass right here in grams, which is the one that actually matters for us right now. You could do volume if you wanted to do everything here in liters. And then we also have particles. Okay, particles when you're leaving and when you come back. So every time you leave, you multiply when you leave the mole. And every time you come back, you divide. And what are our conversion factors? This one is molar mass. This one is 22.4 liters per mole. And this one is particles per mole, 6.02 times 10 to the 23rd. All right. So we did this. We multiplied by 2, which is where we were going, over 4, which is where we were from, and that got us to moles here. And now we're going out to grams, so we're going to this section. So I'm going to multiply by the molar mass, multiply by molar mass, and that will get me back to grams. So in terms of a conceptual flowchart, that takes care of that. Okay, let's go ahead and solve this and just see how that goes. And then at the very bottom, I'll show you the stoichiometry for what that looks like. But you can totally just do the stoichiometry, but unless you really know what you're doing, I think conceptually having a flow of what was going on really helps. It is like always really helped me, and I hope it helps you too. But you can get it with just doing stoichiometry, crossing out units. It's cool. So we have 5 grams and we divide by the molar mass here. So in terms of stoichiometry, we'll show that at the bottom. We'll just do one step at a time. The 5 grams of this is iron. Whenever you do the actual stoichiometry, you got to put your units down. So 5 grams iron over 1. And I'm going to divide by the molar mass. So now, whenever you do stoichiometry, your first step is always to bring those units down. So we have grams of iron that we have to cancel. And now we're going to moles. So I'm going to put moles of iron. And when you see grams and moles, like grams and moles is your dead cue that you're talking about molar mass. So you have a gram-mole ratio that's going on. So our grams number that's in front is 55.8. And this is also why I write this out like this, because it helps me to know what is the number in front of grams. It's 55.8. What is the number in front of moles? It's 1. Okay, so that is going to cancel grams of iron and get me into moles of iron. So let me plug that in and we'll figure out what this first value would be. So this would be 5 divided by 55.8. And that is 0.0896. Let's just round that to 0.90. Oh, not 0.90, 0.090. 0.090. 0.090. Okay. Now, to get from here to here, our next step is doing the next molar ratio. So in terms of my stoichiometry, what I would do is I always bring down my current unit that's on the top, or the one that I need to cancel, in this case, moles iron. So moles iron. And what are we trying to get to? Moles of this iron oxide. So I'm going to put moles up here at the top of Fe2O3. And what are the numbers? And these are the ones from the balanced equation. So my moles iron was 4. My moles iron oxide was 2, right there. So in this way, you don't have to memorize going over from, but going over from, I don't know, I can't think of any. Probably doesn't work at some point, but most of the time it's going to work. Going over from, so that cancels moles iron, and that gets us, let's multiply our current number that we had by 1/2. 2 over 4 is 1/2. So let's multiply that by, and I'll just do that, 2 divided by 4. My son is whispering in the background here. He should definitely be asleep. 0.045. So this is 0.045 moles of iron oxide. Okay, so that took care of moles iron, that would cancel. And now we need to get to grams. So to get to grams, I do another one, and again I bring this down. Moles iron oxide, Fe2O3, okay, and I'm going to grams of iron oxide. So I would put grams of Fe2O3 right there. And what is my, okay, again, let me just reiterate here. We got grams and we got moles. When you see grams and moles on top and bottom, whether it's moles, grams, moles, that is your go-to molar mass, okay? So we have molar mass here, and it's the molar mass of the thing that we're talking about. And in this case, it's iron oxide. And we already found that to be 159.6. So let's plug in 159.6, and this is we could write it like this, 159.6 grams. So next to grams goes 159.6, and this is per 1 mole. 1 mole right there. Okay, make sure we're still all kind of in frame here. Hopefully I didn't cut everything out of frame for a while. And when I do that final bit of math, let's multiply that by 159.6. 159.6. That gives us 7.15 grams of iron oxide, okay? That is how you do those. This middle section is kind of what's going on in my head when I do these. This is how I show that conceptually with columns on doing an equation, and you can do this backwards, you can do it forwards. So if that helps you, awesome. And if you can just find it doing molar mass, then you're a champ, and you're doing way better than I could do when I was in high school and definitely early college. I feel like this really solidified for me when I started teaching, really. So if you can figure that out early, it's super, super helpful. Just lost my light. You're gonna use it all the time. I'll let you go. Have a great night. We'll come back. We'll do some more homework problems and whatnot again soon.